Okay. So, regression is the relationship that exists between variables. So, can you give me two variables in our world that are related? One affects the other. Okay. Can you give me an example of two variables that impact each other?
Weather and sports. The sun and plants. And any students.
Okay. Photosynthesis. How about let's go with this? How about we go with heating cost?
No, I don't want that one.
Make up your own. And temperature. Do you think that heating cost and temperature are related? You are absolutely right, Joshua, that there are ways in which you might see this worked around, but the fact is that if you look at 90% of households, heating cost does impact, or temperature does impact heating costs. You also brought up the fact that there are other ways to heat your house. I have never found a method of heating a house that has absolutely zero cost. So if we did, okay, got it. So here's another one. Education and income. What do you think?
I don't think that one's true at all.
You don't think it's true at all? Not at all. Like if we look at general trends, you don't think that there's enough suggestion to say that the more education you have, that generally speaking, that the higher income you have. You don't think that that's true?
Well, most of the richest people in this world are high school dropouts.
Okay, most of the richest people in this world are high school dropouts. Got it. Okay. Okay, so Josh is correct that there are a number of examples of people who earn a lot of money and yet don't have a lot of education. But we're asking general trends, and the strength of this relationship would be fairly high. Education generally leads to more income and more opportunities. That doesn't mean it's true in every situation, but without a doubt, it is a general trend. Now, what we want to know is the strength of that relationship. Is it 100% true? Is it 80% true? And we come up with a value of correlation. Correlation is the measure of the strength. Of the relationship. So as we're measuring the strength of the relationship between data, we would say, is it strong? Is it weak? Is it moderate? Or we'd say that there is maybe no relationship that exists among the data. So as opposed to just throwing out variables out there and have people opine and respond to whatever their thoughts are, we as statisticians like to gather data and give a number to say, here's how strongly these things are connected and related. And that helps us. A lot of times in regression, we come up with a best fit line. It is a line of y equals mx plus b. It is a prediction line. An example would be like heating cost is equal to, say, 5 times the temperature, probably negative 5 times the temperature, I don't know, 5 times the temperature, plus 20, something like that. And we can then use that to predict what heating costs would be at a given time. We're going to come up with a correlation coefficient. Correlation coefficient is an R value. And R always exists between these two numbers, 0 and, R exists between -1 and +1. So for example, R could be equal to 0.95. R could be equal to negative 0.2. R could be equal to 0. So when we look at correlation, we take all sorts of sets of data and we plot it. And then we see what kind of a line does it make. So if you have an R value of 1, that's an extremely strong positive relationship. So those are two things that are really, really highly connected. For example, in football, do you know the statistic that is the best predictor of who wins the game in football? Number of turnovers. Okay? Your team turns the ball over, you're less likely to win. That's probably the number one statistic. Probably the number two statistic is the number of rushing yards you have in a game. Okay? So if you see an R value of 1, you're going to see data that is scatter plotted but basically forms a line. Like when you look at it, you're like, there's no doubt there's a line that can fit right through that. If you get an R value of 0.5, that means that it's still positive, but it's moderate in terms of strength. What that means is that the data doesn't fit in a nice, perfect line. It's a little bit scattered. If you had to, could you draw a line that you feel like represents that data? Sure. For example, in the first set, it's easy to just say, well, obviously the line's going to go just like that. In this data, you might be like, well, let's, maybe that's the line. Maybe it should go up a little bit. Maybe it should go down a little bit. But that would be about an R value of 0.5. Okay, you see it scattered about a little bit more. Anybody want to guess what it looks like if you have an R value of 0? Go ahead and pair and share and see what you think it would look like if you have an R value of 0. Go, talk. Anybody thoughts? R value of 0 means that we really have no relationship. That means it would be really difficult to try to draw a line. So if your thought process came up with something like this, where there's just data scattered everywhere and there's really no way to draw it, that's an R value of 0. We can't figure out how to draw a line through that data. R value of negative 0.5, what that means is that you have a relationship. It's not real well defined, but it's in the negative direction. So if you were to draw that line, it would be trending down. That does not mean that the slope is negative 5. R does not mean slope. It does mean that the slope is positive or negative, but it is not the value of the slope. So this is a moderate relationship, and it's negative. That's what we know. And if you have R value of negative 1, and I'm going to try to do this for effect so that you understand, that means that the slope is going to be negative, but it doesn't mean that the slope is negative 1. So obviously with taking your math courses, you know that this is not a slope of negative 1. Negative 1 would be like that. The 1 means that it's a very strong relationship. So it'd be very easy to draw a line through it. So it's negative and it's strong. So what I'd like you to do, so you can get a feeling for this, because you're going to have to be able to do a kind of a matching portion on your test. I want you to just draw 4 of these and see if you could roughly sketch what you believe to be a scatter plot that matches those pieces. Just approximate, okay? That matches those pieces. So I've got a general sketch here. Yours could be slightly different. The first one, R.4. I should be able to see that the data definitely has a trend in this direction, but it should be a somewhat weak relationship. I should see data scattered, but definitely going up. Is that what you guys had? Weak, but kind of, scattered, but definitely still a little bit of a trend up? R negative 0.96. 0.96 is really close to 1. So I should see a drop, okay, positive to negative, and I should definitely see that it is really tightly gathered. So this would be, a strong negative relationship. Letter C often confuses people. They see the negative right away, but 0.02 is really close to what number? 0. So I should see no relationship here. And then finally, in this situation, we have R is equal to 0.89. That's closer to 1. I should definitely be able to see a difference. This is what I'm looking for, okay, between D and B. The data for B should be more tightly connected, okay, make more of a line than for letter D. D, I should see a little bit of some, just disparity of data. If I were to draw a line, not everything would be on that line. It would be floating apart a little bit. So this would be a strong relationship, and it would be positive. So that's what we're looking for. Once we can find a relationship between data, a lot of times we can make predictions. But we must make sure that that data is related. So flip it over. Let's talk about these couple things. We won't get to the scatter plot today. We'll be running out of time, but we can at least think about the data, and then we can make a point here. Temperature in degrees and heating bill in dollars. Do you think that those are related? I think that they probably are. We'll plot the data to see if they're related. What do you think causes what? Does the temperature cause the cost of heating, or does the cost of heating cause the temperature? That's what we would think, right? And when you can see it as plain as that, you always make whatever causes something, that's always the X variable, and then the one that is affected is the Y variable. So we call the X the independent variable, and we call the Y one the dependent variable. So the heating bill is dependent on the temperature. So sometimes you might wonder, well, how do I tell? You have to be able to think that through. Okay, that's kind of one of those common sense pieces. You've got to be able to think that through and understand that your heating bill is going to depend on the temperature. And just because it's not like you could go to your, it's not like you go to your local utility service and say, I only want to pay $30 this week for heating, and then expect the temperature to go up outside. That ain't going to happen, right? So what do you think is the relationship? As the temperature goes up, what do you think happens to the heating bill? It should go down. So we should see a negative R value when we actually check it out. Okay? And we can do that pretty simply. We'll do that tomorrow. Now, as we do that, just because we see relationship exists between two variables, that doesn't mean that one always causes the other. And here's one for you. Okay? Suppose that I look at these two variables. Okay? I look at average number of TVs. And I look at literacy rate. What is literacy rate? Yeah, if you can read or not, right? And one of the highest predictors of poverty in our society is people's ability to read, okay? People who can't read, they struggle to find jobs. They struggle to be employed. This is a huge concern. Now, do you think that there's a relationship between the number of TVs that exist in people's household and their ability to read? Maybe, maybe not. Who knows? Okay? Now, the fact is, if we look worldwide, we would see that if the average number of TVs in worldwide is like, say that there's only like half of a TV in every household. So only every other house has a TV. The literacy rate in that country might be like, say 34%. Now, I don't know about you guys, but I got more than one TV in my house. Facts? How many you got? 4? Okay. So let's say we look at the average American household and we've got like 4.3 TVs in the house. and that the literacy rate in America is 89%. Okay, now here's the interesting piece. Is there a relationship that exists between the average number of TVs and the literacy rate? And the answer is yes if you look worldwide. So if we want to increase literacy rate, should we just start adding TVs to more households? What do you think is the factor that is impacting both of these to go up? What's that? Income. So the fact is that income within these countries is making both of these more possible. So sometimes there's a variable that you don't see that's impacting it. And honestly, our world does a very poor job of sometimes explaining those extra variables that may impact. So put that away. We'll pick up with that tomorrow. People who are gone for Big 9, there will be a video. Please make sure that you watch it this weekend. It will not be lengthy, but there will be something.